Hey, John here. Let's look at the standard generator algorithm. And first, let's look at an example of the environment within which you'd like to use such a thing. So let's say I create a program, and for whatever reason, I need to create a list, and it has to fill up with some values, and I want to print it out. Okay? Now, obviously, once this list is created and filled in, you'd put some real useful logic down here. But right now, let's just focus on how do we create this container and fill it with stuff so that later on we can do something with it. Now in this example, obviously, what we're trying to do is put some test data in here, all right? So I'm going to create a list of strings, right? And then I'm going to append on the end of the list each time, right? I'm going to insert at the end an A, B, C, D, E, F, G, and then I'm going to run through here with a range-based for loop and print it out. Okay, so let's compile it up. It should come as no surprise that the list filled up with what I put in there. Let's look at what happens with a generator here, okay? Keeping in mind that, if you wanted to put, say, 100 items in that list, or 10,000, or 1,000,000, right? I mean, this is really not the way to do it up here, right? I mean, I don't want to put 10,000 things in this way. Okay, so that's the whole point of this generator function here. This thing is going to be useful to put in as many as I'd ever want, all right? Let's look and see how this is set up. I create my list just before, but I'm using a different constructor here. As is the case with all the containers, if I leave this out of here, right, what happens? I'm generating an empty container, right? If I put a 7 in here, what I've done is I've created a container of type list that holds string values, and I want to initialize that list by having 7 elements put into that list. Okay? Now those 7 elements are default constructed, right? So each one of those elements will have a string in it that has been constructed with no arguments. So there'll be basically those are empty strings with 0 characters in them. All right. So then the next thing I do is I come down here and I run this generate function. Let's look and see at the doc from CPP reference on how the generate function works. So this is defined in the algorithm header. Okay. Hopefully I included that. Yes, I did right there. Okay. So what does this thing do? This is a template function. Right? And there's a couple of different ways to call it, right? We're going to call it with a first and a last, the begin and end kind of a situation, right? An open-ended range. And then we're going to give it a generator function, okay? And what it's going to do is it's going to do this. It'll assign every element in the range from first to last, our favorite open-ended range here, like is the case with all the standard template library things. Values that are generated by the given function object G. Now notice it says function object here. We'll see more about the value of that in a minute. We're going to just send it a function right now, okay? So down here, this is nice. It actually tells you, for example, inside the library, this template might actually be, implemented like this. And it probably is. Let's look and see what this thing does, right? So the generate template itself, right, which is this right here, the fact that I'm calling something that looks like a function, right? Here's my open-ended range, begin to end, every element in this list up here. And the third argument is gen. That's a pointer to this function up here. Whenever you say give it a function, in a C or a C++ program, without the parentheses after it, what you're doing is referring to the address of the function. Okay? Sort of like an array, right? When you leave the square brackets off at the end of an array, it looks like a pointer that points to the beginning of an array, right? Same thing kind of happens with functions here, right? Leave the parentheses off, and it says this function at this address over here, okay? Okay, so what does it do then? It says I'm going to go from, first is not equal to last. It's going to take the value that the iterator references and set it equal to whatever comes back if I call this function G. And when that's all done, I increment the iterator to point to the next element in the container, come back to the top of the loop. So this is just going to say for every element in the list, in my case, call my generator function, and whatever the generator function returns, which is going to be a string here, set each one of the elements in my list over here to whatever this thing comes back with, right? So let's look at this function real quick. What does it do? It's got a static variable in here, right? So that means that it'll be initialized to 0 and the program starts, but it will be retained, right? So if I say toString and I give it a counter, it'll just take the integer value, turn it into a standard string, add 1 to this counter so that the next time this function's called, it'll say counter is 1, and then 2 and 3 and 4, right? So this will persist its state because it is a static class variable. Okay, so what I'm doing now is I'm going to assign each one of the elements in this list a string value that happens to have a numeric, a digit in it. That's okay. For this demo, who cares, right? It's just got a string in it. Let's go fix this. I must have deleted that character while playing around there. Let's compile it up. And there you go, it works. So each one of these elements in my list, I had 7 of them. They used to say A, B, C, D, E, F, G. Now they say 0, 1, 2, 3, 4, 5, 6, okay? Now, keep in mind those are, in fact, strings and not integers, right? Because I convert an integer to a printable string here when I return it. So what's the benefit of this? Well, for one thing, I can do that now, and it'll still work. And now I have 100 items in there, and I didn't have to hard code them all. Okay, that's pretty handy. Let's look at another way to use this. Now remember, this thing over here, it refers to this as a function object down here, not just a function. Okay. Now in C++, you can create a class like I did here, my generator. And if you provide an overloaded operator with parentheses here, right? The parentheses is an operator that means invoke this as a function. In other words, if I have an instance of a myGenerator class, I create an object of type myGenerator. I can treat it like a function in my code down here. All right? It semantically acts as if it is itself a function. But in reality, it's a whole class. So rather than have a function, for example, that has a static integer in it, a private variable in there that keeps going every time you call it, I can create a whole class. I can put all kinds of variables down here, do any kind of a stateful thing I want. And I can even then create multiple of these. That's a really neat idea, okay? So I can restart them at 0 every time, or I could start it somewhere else. This gives me a lot more flexibility, is my point. So what this class does is it says, okay, I want to create a class called myGenerator. It has an optional parameter called start. By default, it'll be 0. When the myGenerator class is constructed, I set this counter variable down here equal to the start parameter that's been passed in. I otherwise have nothing to do. Okay, so it's just an empty function over there. The overloaded function operator is basically the same kind of thing you just saw in the previous example where I just had my gen function. Well, this thing says if everybody treats this as a function, invoke this code down here, and you see the same exact. This is just the same code. I cut and pasted it out of the other one. Return a string, convert this thing to a string. All right, so that's the current counter value, and when you're done, add 1 to it, so the next time it calls, it gets the next one, and so on. So how does this one now work? Up here is the same thing. Let's put it back to 7. I was just playing around with it. And what do we want to do here? The only difference here is I actually say myGenerator 40 over here. Now that actually looks like I'm calling a function, right? But I'm not. This here constructs an instance of the myGenerator class, and it passes 40 in as the argument to this constructor. after this class has been constructed, it passes a reference to it to the generate template function that then executes this code down here, treating my class instance as if it were a function. All right, so in other words, it's going to call this, just like it used to call my gen function in the last example. All right, so we got a little bit of flexibility here now. I can, because the way I designed this particular class, I can give it a starting value that's different than the default. I can actually create more than one of these in my program and have them all start at different places, right? And they don't conflict with each other. In the previous example, no matter what happened, every time I called that gen function, it just picked up where it left off. So I can only really have one range of numbers. I can't reuse it and reset it and restart it, okay? This gives me a little more flexibility. If you're not used to or not comfortable with this kind of notation, that is the exact same thing as this. Oops. All right. Create one and pass it in like this. All right. Now I slightly lied, right? Because the scope of that generator, if you put my generator and construct it right inside here, the scope is limited to the tenure of this function running. In other words, when the generate function template function returns, this thing would go out of scope. Okay, and when I had my generator constructed in here, it would be destructed at that time. If I do it like this, now it really is the same, right? Remember the rule is inside curly braces, right? Any variables that are declared in here go out of scope down here, and if it's an instance of a C++ object, it'll be destructed. So this here with the curlies and all this other stuff is the exact same thing now as I showed you before when I had generate with my generator 40 in there. Let's go ahead and compile this up. And then you've got your 40, and it ran for 7. Why did it run for 7? Because the list is constructed with a 7 in there. Let's put a 20 in there. Run it again. Now we've got 20 of them. Okay, so now we have a little bit more flexibility. I can start it at any point I want, or just delete this entirely, and when it's constructed, it will then take the default, which was 0, right? So now I've got 0, and I still set to 20 elements in the linked list up here, right? So I got 20 of them. Let's put this, I mean, you normally wouldn't do that. That's kind of messy. Not good practice. What you really want to do is construct it right here. And if you do that as a parameter to a function, it will construct a myGenerator object instance with the default. We can now run that one. Oops. And we're going here. All right, so this is all there is to a generator. It'll take anything that looks like a function, either an actual function or a class with an overloaded function operator, and then it will invoke that for every element in this range. And it will assign a new value to each one of those elements using essentially this logic right here. That thing represents the element in the container. More accurately, I suppose that does, right? Take the element in the container represented by the position referred to by the iterator. Assign it the value that came back from calling this generator function over here. When you're all done, go to the next one, until it's done, right? Okay, that's all there is. Thanks for watching.